Hi, good afternoon to all. This is Asik Kumar. Um a warm welcome to all for this scalar diagram tool training. So, I'm Shashi Kumar. I have 14 years experience in the field of TQM as well as for the continuous improvement. Today, we're going to talk about and see the scalar diagram. So, this is the today topic of content for the introduction, scalar diagram, types of correlation, degree of correlation, how to plot scalar diagram, what is who need to interpretation for the scalar diagram for the application point of view. So basically we will start the scalar diagram. Why the scalar diagram required? What is the purpose of scalar diagram? See, in the SPC or problem solving or any kind of tools or any kind of approach, you want to see the correlations between the two variables. Say example, time and speed and velocity, temperature, and distance travel. So kind of small example we will see about the scalar diagram, but mainly the scalar diagram actually is a graphical view. Is to see the n number of data. It compressed actually a small graphical kind of view. It is called scalar diagram. So it is actually available in the Excel, very friendly, usable, very easy way of plotting the graph. So the scalar diagram is very important to see the two variables, how it is react, how it is correlate, dependable. So it is a pair of numerical data with the one variable of the each axis to look the relation between them. So it is a very easy tools for the problem solving. We can use it. And it is used to study the where we can say that it is used for the dependent and independent. What is a dependent and independent? So example, we can take a XY axis. So example, we are going to travel particular 100 kilometer distance navigations, but we are running the scooter 40 kilometers per hour. So we can able to reach in around 2.4 hours. But we are going for this speed of 60 kilometers, we can able to reach 1.5 kilometers. So when we increasing the speed, they're reducing the distance. It is a simple example, but it will be a very common example. So I taken that actually. So that is the independent dependent variable. So dependent variable will react on the independently for the over the period. So example, this is a scalar diagram. This is scalar diagram. We can able to see the graph point of view. So R value as well as for the how it is acting to each other. So mainly how it is appear the scalar diagram. When you see the scalar diagram, it will appear basically four form. One is positive correlation, negative correlation, curved correlation, positive correlation. So why it is required? Say example, we are collecting data, temperature for the period of one more. Assuming you are in the industry, so you have n number of presses. Say example, 200 presses, but the temperature of each process different. Time is also is considered for the 5 minutes, 10 minutes, or 1 hour. So we want to populate the huge data, seeing the nature of how it is acting at temperature by the climate change over, say morning to evening, or morning 10 a.m. to 12 p.m., 12 p.m. to 2 p.m., 2 p.m. to 4 p.m. How it is acting over the time. That is a very important. We want to see the correlation. So that kind of situation, we can easily can we see the graphical point of view scatter diagram, positive scatter diagram. In the scatter diagram, we can say positive correlation, negative correlation, curved correlation, positive correlation. So example, you can take a positive correlation. Say, so when we are choosing a, I will take a pinpoint. When we are choosing a positive correlation, in the positive correlation, all the value moving from 45 degree or 60 degree aligning as a line. You can draw the line in the middle of the scalar diagram. All the point is closely to the aligning the center line or the line. It is called positive correlation. The direction should be the forward, increasing stage. Negative correlation, it is very opposite. That is decreasing arrow mark with aligning all the values or 90%, 95% of the value aligning as a straight line. If you're drawing straight line, it will be up here nearest point. not beyond that. So example, curved correlation. The curved correlation a little bit difficult to understand, but anyway, it is going increasing. Some point of view, some condition, it is decreasing. So we can able to see there is a basically the independent variable acting because of the time oriented. So in this curve, it is called a curved correlation. Mostly it is very less, but actually when we are occurring this in your data or in your problem solving, we have to see in depth because compared to positive negative correlation, it is very dangerous to the process. The partial correlation. The partial correlation, we are plotting the data, but the actually it is appearing 80% of data or 60% data of correlation, remaining 20 or 30% is no correlation far away from the group of data. It is called partial correlation. So it is very rare, but when we seeing this data type of data, it is clearly indicating it is data error or new manpower or calibration error. Somewhat the external noise is there. So replication values. We want to calibrate our forum first. It is clearly indicate some error in the process, not for the process deviation. So we can able to see this type of data also is a noise in the process. So this is the four very important correlation study of scatter diagram, how we need to see in the from the readings. Next, the degree of correlation. So degree of correlation as well as for the positive negative correlation, but it is very different. It is a percentage of correlation, no correlation, it is scattered around the data, around the graph. Low correlation, it is likely occurred the line, it is not most of them. Medium correlation, it is occurred properly, but somehow it is different from the no correlation or low correlation. High correlation, it's very strong in the system. You can take this correlation. It is a perfect to the analysis. Many problems will occur. We can able to solve by using this with the simple problems. We can see the correlation. We can take the corrective action for the one fact, two factors. If we are taking a two factor, temperature, pressure. When temperature increasing, when temperature, you can assume x-axis, temperature increasing, the pressure is dropped. So what we can able to say, there is the correlation between temperature and pressure. But so this will be a first indication in observation stage. We can able to solve the many problems in observation itself. That is called high correlation. It is a very useful for the problem solving. Then we see the degree of correlation in graphical view. That is already we have seen all the before that positive negative correlation, degree of correlation. But now here we can able to see the how it is very strong depending on the R value. So it is very important point of view. We are explained the two slides how it is appear, type of correlation, degree of correlation. Now we are jumping into mathematical point of view, R value. So in this R value, we are calling correlation coefficient formula. Actually, basically, it will appear in your Excel very easily. When we are taking the chart, it will appear R value. But I like to explain how it is come. So example of X, the R equal to the root of n, that is sigma, summation of xy minus ex and ey divided root of x square in the bracket of x square en x square minus n x whole square and into in the bracket of y square. That is meaning of that is the two dependent. We are taking dependent, independent, dependent. That is two we are adding and we are dividing and we are seeing what is the exactly in the population around R values. That is R values in some of the cases in mathematician or traders, they're using the R value, predictable value kind of thing, which is the correlation what is the next value. So we will see in the R value mostly it is a 1 minus 1 or plus 1. So it is around 0.9597. It is nearly correlation or plus 1 plus 1.2 plus 1.3 strong correlation. Our correlation will be better. So this kind of action we can take for the negative or positive correlation in the form of formula. First, we are seeing for the formation type and appearance and positive and correlation. Now we are seeing for the R value. Then we are moved to the steps. So it is okay. Now we understand why scatter diagram used in the problem solving approach and what is the appearance, how it is appear in the four form of scatter diagram and how it is spread data over the chart is at a degree of correlation. And we are seeing already R value. What is the importance of R value? It is minus to plus. And if it going to the minus value, is a negative correlation. Going to the plus value, it is a positive correlation. Now we are going to the step of how to plot in the scatter diagram by using Excel. Instead of Excel, we can do the manual, but it is very lengthy process. So now we're now all about going for the digital. So we can see how it is used in the using of Excel. First, we have to step one. We have to identify which data we are going to measure. What are the two variables we need to see in the problem solving? After selecting the two variables, basic cleanness of data error or data confidentiality and gauge error. What are the things you are already seeing? It's a basic kind of thing. So after filtering everything, you can take a two variables which is you need to going to measure or need to plot the scatter diagram. You can select. Then after you open the Excel sheets and select the data and select the scatter diagram tool and enter. That's it. Say example. So step one, you can enter the data. Say example, salary versus expenditure, and you can see and you can able to see the chart insert, go to the insert and select the chart of scatter diagram. In the scatter diagram, you can select the insert and choosing a chart. In the chart, the scatter diagram appear. What are the charts? Is there many charted scatter diagram charts available, but my preferable, you can go with the first one. So it is very better for the basic level. Then you can advanced level, you can choose anything like a bubbles or somewhere. But basically, you can try the scatter diagram for the first one. It is a pointed kind of view. So you can choose the first one. Then you can see the uh, data which is appear. It will appear like a XY axis. Then this R value, once you select the data, you can over the pointer, you can say right click and click the R value. It will appear the R value. Then after the R value, you can able to get the interpretation. As we discussed the R value of minus to plus, minus value positive correlation, sorry, minus negative correlation plus positive correlation, then we can take a decision. So ultimately, scatter diagram very useful not only for the problem solving. If any kind of data, if any kind of simple, see example, you are in the going to correct some YY analysis in the machine. So if you are if you are worrying about or you are suspected for the reason of varying the dimensions versus noise decimal or varying the bearing frequently, it's the failure of bearing the oil lubricant value or oil temperature. What is the value temperature of past 1 week by the 2 hours frequency? What is the bearing or bearing varying dimensions or failures occur past 1 year or 6 months? You can able to relate two things. You can get the data of bearing varying correlation of because of oil temperature. Say example pressure. The frequently the pressure is drop when the rainy season or in the morning or in the evening. So what is indication? The temperature of surrounding affecting the inner machine or surrounding machine. So whenever the temperature pressure oil is getting a low temperature, it's a fluid density high. So pressure is not maintaining or drop or excess. Whenever the oil temperature viscosity is high, the pressure is drop. So we need to see the oil dimension, oil kind of oil choosing, or the pressure is whenever the pressure dropping, what is the pressure settings, optimized pressure of based on the climate conditions. Say example of the winter season, summer season. So many problems we can able to solve by using the simple chart of scatter diagram. So that is the beauty of scatter diagram. So this is my short lecture. So I will take another 7QC tools or lean management tools upcoming videos. So I request please watch all the videos and learn. If you anyhow doubt, you can kindly give your comment. I will be refine or I will be do the better for you next time for more practical example. So finally, our guru says you can't manage you you can't manage what you do not measure. If you measure, you can able to manage. That is the uh, good message received from Dr. Edward Deming, TQM Guru. Thanks a lot for watching my videos. Thanks.